Zero is my hero.
Welcome to the adventures of Math Girl. With the help of Pocket Ronnie, you also can become a trusty sidekick of Math Girl like PreCalculus and the Daring Derivative.
Counted on our fingers and toes. Now you're here to stay.
Okay, we're going to be solving some simple equations that are in exponential form and log form. So looking at 21C7, you have this equation. The best thing to do when you have your variable in the exponent is, and it's set up like this, look to see if you can make these bases the same. This is in a base 2. Can we put this in a base 2? Yes. So we have 2 to the x squared minus x equals, okay, 2 to the what is 64? 2 to the 5th, 2 times 2 is 4, times 2 is 8, times 2 is 16, times 2 is 32, times 2, oh, that'd be to the 6th. 2 to the 6th is 64, okay? When your bases are the same, you can now set these exponents equal to each other, okay? It's like if I had 2 to the x equals 8, okay? So I'm going to make this 8 into a base of 2, which is 2 cubed. Well, what does x have to be? This x has to be a 3. So this has to be equal to this in order for this to be a true statement. So as long as your bases are the same, then you can set these exponents equal to each other. So I can set x squared minus x equal to 6. And all I'm doing is setting my exponents equal to each other. Okay, I've got a quadratic equation. How do I solve that? Set it equal to 0. So x squared minus x minus 6. I just subtracted 6 to the other side. Now I factor. I should have two solutions. So first I see if it factors. If it doesn't factor, I use quadratic equation. But I'm pretty sure this will factor. This sign tells me one's going to be positive, one's going to be a negative. Now I need factors of 6 to where I get a negative 1. So that would be a 3 and a 2, and that should give me a negative 1 and a negative 6 here. Now you set each of these equal to 0. Now solve this. So this would be x equals negative 2 and x equals 3. Those are the two different solutions that you can have to make this very top thing a true statement. Okay, I need to correct myself. Up here, when it doesn't factor, I said use quadratic equation. This is a quadratic equation. When this doesn't factor, you use quadratic formula to solve, but it did factor. Okay, so now we're looking at 21D, number 9. This is in log form. Log base 2 of 32 equals x. Get it out of log form to solve it. Okay, so how do we get out of log form? This is your base, 2. This is your exponent, so 2 to the x equals 32. Now we treat it just like the problem we just did. If we can get these both into the same base, then we can set our exponents equal to each other. So 2 to the x, so I'm putting 32 into a base 2. Because since this is in a base 2. 2 to the what equals 32. 2 to the 5th. Now that my bases are the same, what does x have to be? You can see x has to be 5 in order for this to be a true statement. So I'm just setting this exponent equal to this. So x equals 5 to make that a true statement. Okay, now we're looking at 21C9. Again, this is in log form. We need to get it out of log form and put it into exponential form to solve. So log of base 3 over 2 of 4/9 equals x. So this was my base. 3 over 2 to the x is equal to 4/9. I need to get both sides in the same base. So I need to get this to match this. So I do know that 3 over 2, this is like if you want to say it that way to the x, changing 4 and 9 into bases of 2 and 3. 4 is 2 squared, 9 is 3 squared. So instead of saying exponent each one, I can just say whole thing squared. Do my bases match? Not yet. This needs to be the reciprocal. When I do the reciprocal, when I change the place of each one of these, what do I do to this sign? I change it. So when I change the place of each one of these, I have to change the sign. So now I can say 3 over 2 to the x is equal, taking the reciprocal, changing the place of each one of these, means I have to change the sign of my exponent. Changing the place of your bases means change the sign of your exponent. So now it's to the -2. Now these match. Now I can just set my exponents equal to each other. So that means x has to be a -2 in order for that the original problem to be a true statement. Okay, we're looking at 21C8. It's in log form. It needs to be in exponential form in order to solve it. Okay, log base x. That is your base x. So, and that's your exponent is equal to 64. I'm trying to solve for x. X to the 6th. What do I do to get rid of that 6? It's to the 6th power. I have to do the opposite of raising it to the 6th power, which means taking it to the 6th root. So do the 6th root of 64. This and this cancels. The 6th root of 64 would be 2. So x equals 2. Okay, now looking at 21B7. This is an exponential form. When it's already in exponential form, the best way to solve these is to put these in the same base. So on the left, I have a base of 3. So on the right, I want to put 27 into a base of 3. 3 to the what is 27? That would be 3 cubed is 27. So now that my bases are the same, I can set my exponents equal to each other. So I have x squared plus 2x equals 3. It's a quadratic equation. How do you solve a quadratic equation? Let's move this over and set it equal to 0. So subtracting 3 from both sides. Now the first thing you want to do is see if it factors. If it doesn't factor, you have to use quadratic formula. This one will factor. This sign tells me that one's a positive and one's a negative. The only factors of 3 are 3 and 1, but I want a positive 2 here. So that means I need a positive 3 there, negative 1. Setting them both equal to 0. And then solving, that means x can be a -3 or x can be a positive 1. Either one of those will make this a true statement.